Hello. In this module, we'll be discussing median and mode as the measures of central tendency. The median of a finite set of values in an ordered array is a value that divides the set of data into two equal parts. Median is the number of values equal to or greater than the median is equal to the number of values equal or lesser than the median. If the median is calculated for the population, it's represented by mu with this curly at the top, which is called mu curly is the median. But if it is calculated from sample, it is denoted by x curly. Median is actually the n plus 1 by 2th value. Median, to calculate median, we need to follow different steps. Since we already discussed that median is calculated for ordered array, so the first step in calculating median is to order the data into ascending order. Though it's not necessary to do it in ascending order all the time, but it's always easier to deal with. Then in the next step, we assign an index to each data point. In the step 3, we calculate median index by calculating n plus 1 by 2, where n denotes the number of observations in the sample. A data point in an ordered array that corresponds to the median index calculated at step 3 will be a median value. Median for odd values is obtained by arranging the data and calculating this value by n plus 1 by 2th value. Here you will be able to find a unique value that goes right in the middle, which is not the case with the even data size. Let's take an example to calculate median. The white blood cell counts of 5 patients entered into the dengue ward in a particular hospital in Lahore are given. And this is the same example we discussed in the previous module where we talked about mean. So to calculate median from all these values, in the step 1, we will order this data into an ascending order. And the values will turn out to be 3730. Then the next value is 4500, 4900, and the last value is 8210. In the step 2, we will assign an index to these values. And hence we calculate n plus 1 by 2th value is going to be the median. So n plus 1 over 2 will turn out to be 5 plus 1 by 2, which is going to be 6 by 2, and it's got to be equal to the third value. This third value is a median. And this is a value above which there are 2 observations, which is 50%, and below it's 2 observations. If the number of values in our data are even, we will not obtain a single value in the exact middle. Rather, there will be 2 values. Hence, the median will be the average of those 2 middle values, which are obtained from the ordered array. Let's take the example and add one more value, that is 3500, into the white blood cell counts. And now we have 6 observations, which is even number. To calculate the median out of this data, we need to order it into an ascending order. So the observation will be in the step 2, we will add the index to these values. And finally, we'll calculate n plus 1 by 2th observation. And the value at n plus 2th location will be 6 plus 1 by 2, which is gonna be equals to 3.5th value. 3.5 lies right in the middle of these two values. Therefore, to calculate the median, we'll take the average of these two values. And it turned out to be that the median for this data is going to be 4,700. And that's how it's just a different. But there are all other different formulas which are used to calculate median. But we want to be very simplistic here. That's why we're just doing only one. There are a few properties of median. And like arithmetic mean, median is a unique value that we get only one value for a given data. It is simplistic as well because it's easy to calculate. It's also reliable. It's much reliable than mean in instances because it's not drastically affected by extreme values. And it can be used when the data is measured on ordinal scale as well. The other measure of central tendency is mod. The mod is the most frequent value in the data. If all the values are different, then there is no mod in the data. A set of values that may have more than one mod. Usually the peak in the histogram or the frequency distribution is considered as the mod. Let's take an example. And if we have ages of 6 individuals admitted to the emergency ward of a hospital after contracting flu, the ages are 18, 22, 17, 24, 17, and 20. To calculate mod, we do not have to order the data. It's only we need to find out that which observation is the most frequent. And in this data, we can see 17 is the most frequent observation. Mod are denoted by X hat if it's calculated from sample. But if it's calculated for population, we denote it by mu hat. For a similar example, if the data points turn out to be 18, 22, 23, 17, 15, and 19, in this data set, we can observe that there is no repetition in the values. And all the observations are just once. Hence, we'll declare that there is no mod. It's a wrong terminology when we say that the mod is 0, because 0 is a legitimate value in the data. So please avoid saying that mod is 0 in that situation. The right answer could be no mod. All the measures of central tendency have some significance. They do have their merits and demerits. It is suggested that they should be appropriately used. Thank you.